Okay, it says give an exact answer. If they want an exact answer, we're going to have to do this without our calculator, right? What have we said about logarithms? Logarithms are exponents. And since logarithms are exponents, radical symbols don't really fit with what we're trying to do. So because there's this radical symbol underneath this, within this logarithm, I'm going to write that as a fractional exponent. Okay? Is everybody okay with that? Does that make sense? All right. Now, you have options once you get to this point. You could have, right from the very start, written this in exponential form. Because it is, look at this equation, this is an isolated logarithm. There's stuff going on the inside, but for my money, radicals and logarithms don't mix. So I want to make sure I write that as a power. Okay. Now from here, like I said, you have options. If you wanted to, what could you do with that 1/2? What could you do with this 1/2 right now? You could write it in front. And you're like, why would you do that, Jackson? We have that logarithm all by itself, and then you had to go and ruin it by putting that 1/2 there. Well, then get rid of it. How do I get rid of a 1/2 that I brought in front? What do? Multiply both sides by 2. So if I multiply both sides by 2, here and here, that 1/2 is going to cancel. Now I've got the natural log of x plus 4 equals 4. Right? A little bit of a sidebar to get rid of that radical symbol. It's not the only way to have gotten rid of it, but now we have an isolated logarithm. There's no radical, there's no exponents, there's no nothing. Now I can take this and write it in exponential form. In case you've forgotten, the natural log is log base e. So we really have log base e of x plus 4 equals 4. And when we have a logarithm that's been isolated, we want to write it in exponential form. To write this in exponential form, the base of the log is the base of the exponent. Logarithms are exponents. So that number that's on the other side of this statement, that's the exponent that I make for e. And then lastly, we set that equal to x plus 4. We're solving for x. And our instructions were to give an exact answer. So remember that e is not a variable. E is what we call the natural base. So this expression here has a value. It has a decimal value, but we don't want to know what it is, because that would not be an exact answer. It would be an approximation. So we're going to subtract 4 from that. To get x by itself, we get x equals e to the 4th minus 4. This is what they're looking for in this problem. Okay? And last but not least, let's remember, when we get our answer to a logarithm equation, we need to check to make sure that it fits back into the original. Now, e to the 4th power, let's talk about this just very briefly. E, in case you've forgotten, e is approximately 2.7, 1828, 1828, blah, 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 blah. So if I raise 2.7 to the 4th power, that's relatively big number, maybe something in the 60s or 70s. So this entire expression is approximate. I'm going to throw it out there because I don't know what the exact answer is, but I'm just going to say it's approximately 60. It's probably bigger than that, right? But if that's approximately 60, let's make sure that I can put 60, sorry, keep going, that I can fit 60 into this logarithm and get a positive value, right? And we can, 60 plus 4, right? That's a positive value, so we're good.